Selamat sejahtera and good day to my honorable panels. Today, I would like to present about my project. My project title is Optimization Water/PV Cleaning System for Rooftop Application. My name is Jivan. My material number is CE210092, and I'm from Faculty of Electrical and Electronic Engineering. And this project is supervised by Technologist Dr. Said Saurul Islam.
Before I continue with my presentation, I would like to show the demo of my project. Today I'm really excited to demonstrate about my project. So here we come. So my project is consists of data logger. So this data logger reads current value, voltage, Pmax and irradiance. So with this will collect the data for the real-time base. And beside here we have the main for the cleaning system. So this system works on a schedule base every 7 a.m. in the morning. So here we can see the real-time base also and the pump activation mode, which is on and off. So we have a manual activation of a button to test for the manual activation. This system is powered with this battery and which is connected with this solar panel. In my cleaning system, I have integrated a rain sensor. This rain sensor is mainly integrated due to consider the real weather condition. If the rain falls, system actually will skip. System have integrated the rain sensor because it will monitor the rain time on the natural time, which is from 12 a.m. till 7 a.m. If any rainfall happens between that time, my cleaning system will skip the activation because the rainfall itself have cleaned the dust or any debris on the PV panel naturally. In my system, I collected the water using the rainwater. So the rainwater is collected from the rooftop of the water gutter. So we can see this is the water gutter, and this water gutter flows the rainwater into my storage tank. The collected rainwater will flow in the pipe and goes to my tank. So here is my water storage tank, and inside the tank have a submersible pump of 50 watt. Here we goes to the main pipe. So this is my implementation setup of the cleaning system. As you can see, we have a pipe here. I've integrated a nozzle, 3 nozzle. So this nozzle will spray the water to the surface of the panel. So and the dust accumulated on the solar panel will clean, and the water will go to this integrated water gutter. So this is the water gutter, and the water after used will flow back to the storage tank. So this is the flow back to the storage tank, and before it flow, it will filter any dust or sand which is cleaned on the solar panel. So let's see how my PV cleaning system works now. I will put a sample on the panel and we activate manually the cleaning system, and we see how the cleaning system works. In the sampling, I have a 10 gram of sand. So this 10 gram of sand will spread on the PV panel evenly and test with my manual activation, which is 15 seconds. So here we go. So now I have spread the 10 gram of sand for sampling on my PV panel. So now we test our cleaning system. Now I will activate my cleaning system with the manual activation. So we can see the 10 gram of sand sampling is fully clean. So this is how my water spread on the PV panel and goes to this water gutter, which I integrated in this cleaning system, and this water will collected back to my storage tank using this pipe flow.
The outline of this presentation consists of why it is important, objectives, method, system implementation, results, conclusion, and references. Why this project is important? Because dustfall occurs on the rooftop solar panel and large solar panel. Because of dustfall, the performance of the PV panel is reduced. So there is a manual cleaning which make a cost because of required labor, and plus the labor will be in high risk because have to clean on top of the rooftop. There is also a water waste in the manual cleaning. So we compare with the different cleaning method, which is robotic system. There are some robotic system, but the robotic system still requires the support of labor. Plus, the robotic system might be effective. However, it is required manpower, and cost of the robot is also a matter. Robotic system might not require under the Malaysian environment because the dust accumulation on the PV panel not that severe. Robotic might be effective in the Middle East environment because of accumulation of dust that is higher. The first objective of my project is to integrate a rain sensor into the cleaning system to automatically suspend cleaning during rainfall, optimizing the cleaning schedule and saving resources. The second objective is to design an automatic water splashing cleaning system with effective nozzle to ensure uniform water distribution across solar panel and maximize cleaning efficiency. This slide represents the method of my implementation setup. On the left hand side, we can see the cleaning system circuit diagram. So in this cleaning system circuit diagram, we can see which is integrated with the Arduino. and with few sensors such as rain sensor to detect the rainfall, and we have RTC to monitor the real time. And here we have SD card module to log the data of the activation of the pump. With we have a manual activation of push button. We have also relay module which is integrated with submersible pump and battery to activate the submersible DC pump. Have a LCD display to see the reading of the rain detection value and activation of the pump. On the right hand side, you can see the system flow diagram. Once the rain sensor is detected more than 400 threshold value, it means it's not raining. If less than 400 threshold value means it is raining. Let's say the threshold value is more than 400, which is not raining, and it will trigger the pump to activate for 15 seconds. So once the pump is activated for 15 seconds, the water will flow through the nozzle and splash water on the PV panel. And the water splash on the PV panel will clean the dust accumulation, and the water will go back to the tank, which is flow from the water gutter, and the water will filter by the disc filter. So here we have with and without cleaning system to make a comparison. So to make the comparison, I have put a data logger. So this data logger will collect the current and voltage value of the PV output. These are the some features of the system implementation. So the system implementation consists of the solar panel integrated with the cleaning system. And the second picture, we can see the harvesting of the rainfall is going to the storage tank. And here below, we have a picture of our cleaning system and together with the data logger. Here we come to the result part. There are a lot of results in my project, and here I will show the few results. So the first result is based on the sand sampling. The sand sampling method is taken on the PV cleaning system. The method is spread the sand on the PV cleaning system and measured the Pmax, which is considered as Pmax non-clean. At the same irradiance, we will clean PV panel and collect the Pmax after the cleaning system. That is considered as Pmax clean. So these two Pmax is taken under the same irradiance value. Figure 1, the red line is considered as Pmax clean, and the blue line is considered as Pmax non-clean. So here we can compare and see the Pmax clean is slightly higher compared to Pmax non-clean, and the yellow line is shown as the irradiance actual value. So in this graph, I will conclude. So the Pmax clean has produced more output power compared to Pmax non-clean, and it is noticeable that the Pmax is lower, 103.52 watt at the irradiance of 1132 watt per meter square, while higher at the 107.91 at the lower irradiance of 1105 watt per meter square. This behavior can be attributed to the STC specification of the panel, which irradiance of 100 watt for 1000 watt per meter square. Since the Pmax of both irradiance level reaches its maximum capability, the insignificant difference in the Pmax can be considered negligible. At the figure 2, we can see the relationship between Pmax differences with the sample weight. So in the figure 2, the graph shows a clear linear trend where the Pmax difference increases as the sample weight increase. This equation of trend line y equals to 1.1765x minus 0.8261 indicates that for every additional 1 gram of sand, the Pmax difference between the clean and non-clean panel increased by approximate 1.1765 watt on average. Next result is based on the luminance. So this data is taken based on the average of 2 weeks data. So in this result, I will explain before I show the graph. So this result based on two panel, which is one with cleaning system and one without cleaning system. So this data taken on the Pmax, which is for the cleaning and non-cleaning system for the same day. So the first figure on the figure 3, we can see this is shown as high luminance day. On this high luminance day, we can see the comparison. The red line is shown as without cleaning system, and the yellow line is shown as with the cleaning system. And the blue shaded region is shown as irradiance value. So in the first graph, the figure 3, we can see the high luminance day is almost reaching the irradiance value above 1000 watt per meter square. On the second graph for the figure 4, we can consider as medium luminance day, which is less than 800 watt per meter square. And the output power for the cleaning and non-cleaning system is low. But as you can see, even the irradiance is low with the cleaning system of the panel, the yellow line shows still a slightly higher of the power output. So on the right hand side, we can see the output power for the high luminance and medium luminance day. So to conclude this, we can see the cleaning system still produce a slightly higher output compared to the non-cleaning system, even though there is a high luminance day or medium luminance. Here we can see how the my cleaning system data logs. So as you can see, when it is 7 a.m. at the morning, the pump automatically turn on. according to the rain value, which is above 400, and the value is above 400, it will activate for 15 seconds. So these are a few proof of the pump activation if there is no rain. If let's say if the rain sensor is value 400, if there is rain, the system skip the activation, which the pump not activated. So data won't save because there is no activation of the pump. So this is the proof I can show. So this day have rain, which is the threshold value less than 400. On the right hand side, this is the data logger for PV panel for both cleaning and non-cleaning system. So this is the data how it takes, and in this data consists of current, voltage, power, irradiance value, and with the real-time base. For the conclusion part, I would say successfully achieved project objectives, which is designed an automatic water splash cleaning system with effective nozzle for uniform water distribution and integrated rain sensor to suspend cleaning during rainfall, optimizing resource use. The solar panel cleaning system successfully enhanced panel efficiency by removing dirt and debris, ensuring optimal energy output. Its automated design promotes sustainability and reduces maintenance efforts, making it a practical solution for renewable energy system. By combining automation, these features work together to create a system that is not only more efficient and sustainable, but also practically for broader adoption. This project highlights a promising step forward in improving solar panel maintenance and supporting the growth of renewable energy system. That's all for my presentation. Thank you for listening to my presentation video.